Pre-calculus students, this is Mr. Hale. I hope you're having a lovely day. I want to shed a little light that may have been blocked from your view on functions. Some of this will be review, but in case that summer has gotten in the way of your knowledge, I'm going to do some things to move on so that your knowledge is in totality, not just the 99% that you may be experiencing. So we're going to start with this. Is the following relationship a function? And you can see we have a couple different formats here. They're kind of the same thing, but essentially what we're looking at, remember with a function is, does any one place in the domain lead to more than one place in the range? In other words, like, is any one x value repeated? If this was x and this was y. The answer on this one, of course, is no. 4, 5, 6, 7, and 8 all each point to exactly one place. So this is most definitely a function. Kind of the same deal on the next one, but we have a little issue right here. You see how 1 and 6 and 1 and 4 are both points? This is not a function. You could think about it in terms of if you graphed these points, you would have a vertical line test failure. As we move ahead, we're actually going to ask, honestly, kind of a similar question on 3 and 4 as we did on 1 and 2. It's worded differently, it looks different, but it's still sort of asking the same thing. Determine whether the equation represents y as a function of x. There are a couple of ways to think about this. One would be in terms of if you solved for y. So here we go. If we solved this one for y, we'd have y equals, well, we'd have to do the square root of both sides. It would be y equals plus or minus the square root of x. Okay, don't forget that plus or minus when you take the square root on both sides. This whole plus or minus thing creates an issue in terms of a function. And actually, if you sketched the graph of this particular function, it would look something, try that again, it would look something like this, where we have a parabola opening to the right. So if you think about that, clearly we are not passing the vertical line test, and therefore this is not a function where y would be a function of x. Sort of the same instructions on number 4, again different layout, but you could go ahead and take the approach of let's solve for y. We could do that by subtracting x squared and then dividing everything by 3. I'm just going to write it this way, 1/3 times 9 minus x squared. I'm not going to worry about distribution. But when I look at this, I see it and I say, you know, I could definitely graph that. It's a parabola, but this one's actually going to be opening downward, which isn't really a problem. And if you're a little rusty on parabolas, you can think of it a different way. What if I asked it this way? Could you punch that onto your TI-84 calculator? Can you graph that on one line of your screen without using any tricks or anything? And of course the answer is yes. Y is a function of x on that particular problem. For numbers 5 and 6, we're going to use the same instructions. It's sort of some hidden problems in here though. So 5 is actually kind of 3 problems. But evaluate the function at each specified value of the independent variable and simplify. Alright, so if we called this one a, in order to find a, we would evaluate h of 3, and remember, to do h of 3 you just simply plug in 3 anywhere you had a t in that function. So this would be 9 minus 15, or just simply negative 6. For number 5, and we'll call it part B here, if you were to evaluate h of 4/5, it's really the same as what we did on part A. It's just a fractional value. But seeing that you're in pre-calculus, fractions don't bother you anymore, so you're totally comfortable with doing something like 4/5 squared. You'd know that's 16 over 25, and you know you'd be subtracting 4, and basically we'd get negative 84/25, because we know 4 is 100 over 25. I'm just simplifying the fraction. Don't panic if you don't do it as fast as I just did. It's all right. We'll get you there hopefully. All right, h of x plus 1. This one's a little different in that we're not just plugging in a number, but actually plugging in a variable. But we follow the same procedure. Anywhere on our function h that has the variable t, we're replacing it. This time we replace with x plus 1. So it's going to be x plus 1 quantity squared minus 5 times x plus 1. Okay, so we just did t squared minus 5t, and anywhere we had a t, it became an x plus 1. Now, remember, when you square x plus 1, you get x squared, and then you get 2x and plus 1. If that's baffling you, write out on the margin somewhere x plus 1 times x plus 1 and use whatever method you use to multiply, FOIL, whatever you want to call it, and see what you come up with. Don't lose the middle term is the moral of that story there. Okay, and then we can just distribute the minus 5, and I'm kind of cutting it close on the edge of the screen there. When we combine like terms, we'll have an x squared. We get a minus 3x plus 1 minus 5 gives me minus 4. So there it is right there. There's h of x plus 1. Notice on that one, of course, that we did not get some answer that we could clean up into just a single number or something like that. That's fine. That's the correct value. All right, on number 6, we're looking at a piecewise function. So that changes things a little bit because first you have to figure out, are we talking about the first rule, which I put the arrow next to, or the second rule? So you have to look at the domain restrictions we have here. So the first rule is for x values that are less than or equal to -2. The second one is anything above -2. So when I see f of -5, I know I'm using the first rule because -5 is less than -2. So I'm going to go here and I'm going to plug in -5. That means -5 squared minus 3, which is 25 minus 3, and that would give us 22. Okay, for f of -2, same thing. First, figure out which rule you're talking about. This is exactly at -2. The first rule is for x values less than or equal to, so that little bar right there is the key. So we're still on the first rule, -2 squared minus 3, which is going to give us 4 minus 3, or just simply 1. And then finally, f of 5. So as you would probably have predicted, I went to the second rule on this one. 5 is definitely more than -2, so we're going to do 5 cubed plus 1, which is 125 plus 1, or just simply 126. So again, the key there, figure out which rule it is. Is it the first rule, second? Some of them you could have 3, 4, 5 rules. It doesn't matter. But figure out which rule and then plug in your number. For 7 and 8, you have to make sure you understand what the instructions are asking you to do. It's saying to find all real values of x such that f of x equals 0. So what that really means is what we're saying is, where does x squared minus 7x plus 12 equal 0? You probably knew that, but you got to think about what it's asking and make sure you do the right thing. Now this is a quadratic, it has 3 terms. These are 3 nice terms actually because it factors nice and clean. X squared minus 7x plus 12 will be x minus 4 times x minus 3. And so we get 2 values. We get 4 and we get 3 is our possibilities. Remember, I'm using the zero product rule. I'm going to go ahead and put that rule down here. The zero product rule tells us that if a times b equals 0, a equals 0, or b equals 0. So in other words, you just set these two terms equal to 0 separately, and you get 2 possible answers in this case. So 4 or 3, either one would give a function value equal to 0. Hey, same instructions on the next one. Only difference here, we're still going to factor, but it's not like group factoring kind of thing. It's more just get a common term out. So here we have an x that goes evenly into both. We're going to factor that out. And then we'd get x equals 0 or x plus 5 equals 0. So our 2 possibilities are 0 or -5. As you might expect, early in a course like pre-calculus where we're kind of building on prior knowledge, there are some times where some of these sections have a bit of a hodgepodge of information, and I would say this is one of them, but this is another kind of review topic. Find the domain of the function. Remember, domain means the possible x values. And so what I know, anytime I have a second root or a square root, I know it has to be a positive number inside there. So I'm going to say x minus 7 has to be at least 0. I said a positive, but truthfully it could be 0 because we could do square root of 0. We can do that. We can do square root of 1, square root of any positive number's fine. But you can't do the square root of a negative. That takes us to imaginary land. We're not ready for that yet. And so here we go. X is greater than or equal to 7. That's the domain. Now, if you wanted to write a little bit clearer notation maybe, and actually, satisfy your advanced algebra 2 teachers, you could maybe write it something like this, 7 to infinity, like that, inclusive of 7. All right, same instructions on the next one, but a totally different situation. On this particular problem, our restricting issue is we cannot divide by 0. So essentially, I just need to solve this, x squared plus 11x minus 42. And it actually can't equal 0, but I'm going to just write it as an equal sign with a slash through it. We'll solve it the same way. Let's see, it looks like x plus 14 times x minus 3. 14 times 3 gives us 42. The difference between those two numbers is definitely 11. That seems like a pretty decent job there. So what I know is that x cannot equal negative 14 or positive 3. Those are the two values we have to avoid. Now we can go ahead and change this in interval notation. This one's a little more complex than the interval notation, but just for reminder purposes, I'll go ahead and set that up. We would go negative infinity to negative 14. It's not inclusive of negative 14, so we do the parenthesis there. And then we use this union symbol. It's like a U. And then it picks right back up as soon as you pass 14 and goes to 3. And then the rest of it is 3 to infinity. Again, it's parentheses everywhere, no brackets. It's kind of annoying and tedious to write it in interval notation, but it probably is our favorite notation in most math classes as you move forward. So it's okay to, deal with a little bit of pain every once in a while on that, and that's one of them. All right, hey, something brand new today. We're going to do what's called the difference quotient. Now, spoiler alert, we're really getting ready for calculus when we do this problem, so it's a little tougher at times. Some of them aren't too bad. Some of them will push you just a bit. And so when we do something like a difference quotient, what I would suggest, this term right here, f of x plus h, is really honestly the key to this whole thing. So I'm going to find f of x plus h on its own before I even try doing the rest of the problem. So I'm going to do 4 times the quantity of x plus h squared minus 2 times x plus h. So all I've done is take f of x, and where I had an x, it became an x plus h. Okay, and then when we square x plus h squared, that's going to be x squared plus 2xh plus h squared. And then, of course, minus 2x and minus 2h after we distribute. And I can go ahead and distribute this 4, and I'm going to kind of clean up all this stuff at the same time. But we'll have 4x squared plus 8xh. There really aren't any like terms, so plus 4xh squared minus 2x minus 2h. Now, just when you thought, man, that problem was kind of tough, Mr. Hale, you realize like that wasn't really the problem. That was just a little piece of the problem. So here's the difference quotient. When we do f of x plus h, that's what we just found, minus f of x, all divided by h, it looks like this. 4x squared plus 8xh plus 4h squared minus 2x minus 2h. That's f of x plus h. Now we need to subtract f of x, and I'm going to put this in parentheses. 4x squared minus 2x, and the whole thing, there it is over h. Give myself a little more space here. And this problem ends up simplifying quite nicely, because what happens is the 4x squareds cancel out. Here's minus 2x, and I know this looks like it's minus 2x, but don't forget you have to distribute that negative, so the 2x's are going to undo each other as well. And we're left with 8xh plus 4h squared minus 2h all over h. Now you might notice everything in the numerator has an h in it, so we can actually factor that out. And some of you probably recognize right away why I'm doing that. Others may be like, why? Well, here's why. Because we're dividing by h, and now those terms are gone, and we're actually left with our, I guess we'll call it the answer. It's the difference quotient, 8x plus 4h minus 2. Now, later in the year, we'll talk about some deeper applications of this. It really truly is a calculus concept. Kind of cool stuff goes with it. For now, we're kind of doing a beginner course on it. We have one more. So number 12, the instructions look slightly different. We're still doing difference quotient, but notice in here, this difference quotient looks a little different than what we did on the last one, but it's okay. We know f of t already. Let's go ahead and evaluate f of 1, and then we're going to use that to plug things in. That's going to make this problem actually a little bit easier, arguably, I would say. And so when we do f of 1, that's 1 over 1 minus 2, so 1 over negative 1, or just simply negative 1. All right, so let's go ahead and evaluate our difference quotient, f of t minus f of 1, and I know it's a little tedious that I'm rewriting this. That's all right. I want to make sure you understand where everything's coming from. So here we go, 1 over t minus 2, that's f of t. We just found f of 1, which was negative 1, and it says to subtract it, so I'm going to go minus a negative or just simply plus 1 all over t minus 1. Now that problem looked fairly straightforward, and all of a sudden now it gets annoying because we have fractions on fractions and we've got to deal with it. So here's what we're going to do. We're going to change a 1 into a t minus 2 over t minus 2. And you notice I did all that as one big fraction. Okay, and so then what we have in the top numerator, this is just simply t minus 1 over t minus 2, and that whole thing is divided by t minus 1. Now it might help you to think about it this way. I'm going to mark this kind of lightly, but if you could think of t minus 1 being divided by 1, and so really, as you know, whenever you have to divide fractions, it's the same as multiplying by a reciprocal. So I can just do 1 over t minus 1, and all of a sudden we see, hey, t minus 1s are gone, and all that I'm left with is 1 over t minus 2. That's our difference quotient. Folks, I hope you're having a spectacular day, and we will see you soon.